So I'm going to open up a data set. So there's an SPSS data set on my SPS formatted data set on my desktop. SPSS data sets have the PostScript .sav. Most people on their PCs and their Macs nowadays, they have them set up to hide the PostScript, but Macs use something called a data fork in their files, so you don't actually have to have it in the file name on a Mac, but on a PC it has to be in the file name. That .sav has to be on the file name. It is on your computers. If you have a PC, most likely you don't see that .sav unless you look at the properties of that file. You get info or look at the properties of that file, but it's really there. It's just hidden. So if you have a Mac and you save a SPSS file or any file without that PostScript, the Mac will be able to recognize what application it works with. The PC will not. So if you can't open a file that came from a Mac on your PC, it's most likely because it's missing that PostScript. And you can just click on the file name and add it, .sav, or for Excel, .xlsx, or for Microsoft Word, .docx. It's a little bit of housekeeping there in terms of dealing with file versions and stuff like that. So I'm going to open up this data file. I'm going to go to Open, Data. I'm going to navigate to my desktop as it happens. And here's the data file that I want to play with right here. It's North Carolina birth vital statistics on births for a number of years ago, but it just happens to be handy that we've used it previously in other semesters. The 800 is because we randomly pared the file down to 800 births from a data set that had all of the births in North Carolina for an entire year, which might have been 40 or 50,000 or something like that. So it's got 800 values in it, 800 subjects in it. So I'm going to open that up. Okay, now notice that it's an older file. It's running this newer version needing encoding called Unicode. Wants to know if we want to use the old version. So we don't really care about it. We'll let it update it. So I'll just say, okay, don't worry about it. Just open the file. Okay, so let's take a look at what we have. As I mentioned before, I think, Louis, I answered your question, right? Version 25 is any version is fine. That's within the lifetime of everybody that's in this class. Yeah, if you're anything in the 20s, it's like going to use probably this newer version of the encoding anyway, just like this version. Let's see, that's just for the hell of it. Let's see what I got here. Yeah, I'm working with version 24 right now. So at any rate, so we have two views of this data. When it opens up, we get a kind of a database, kind of almost like a phone book of data. In the rows are the subjects. Okay, this happens to be a person that had a single birth. Plurality is the number of babies born out of that pregnancy. The gender, obviously, gender is female or the mother. This is then the gender of the baby. The mother's age. Now, notice that M age, I automatically interpreted that as the mother's age. If I hover over that for a second, you saw that it gave me more information about it. Label, it's a label called the age of the mother, and so on and so forth. But I recognize it pretty quickly. Now, that might not be obvious to everyone that might view your reports or your charts or your tables and so on and so forth. And some of these might be confusing in terms of what the variable name means in terms of what the data is. This is the weeks of gestation, the weeks of the pregnancy. This is the marital status of the mother. Now, that's going to be particularly interesting to us because nobody's typing in married or not married here. They're actually just typing in a number, for instance, a 1 or a 2, to indicate that the woman was married or not married at the time of the birth. Race. Now, there's going to be a number of ethnic groups that are represented here, and those ethnic groups are going to be represented by numbers that indicate what that race is. So we need a code book. We need some information that tells us how this data is organized and how it's summarized. So in fact, if I go up here to View and I turn off the value labels here, you'll see the raw data as it looks in the actual file. If I go back to View and I hit value labels, turn it back on. That's a toggle. Anytime you have something where if you select it, it turns it off, where you select it again, it turns it on, is referred to as a toggle. So we have all these fields, all these variables that we're dealing with, whether the mother drank during the pregnancy, whether the mother smoked during the pregnancy. Numerical variables, where we have the measure of the birth weight of the child in ounces, called T ounces for some reason, or I guess total, that would stand for, or T grams, the weight in ounces or grams of the infant. Was the infant premature? In other words, this is a logical value that's associated with the actual weight of the baby. Was the baby premature? Was it low birth weight? Was it so on and so forth? The ethnicity of the mother and so on. So I think those are extra fields that we were playing with. So now how do we figure out or manage these variables, their names, and how they're going to be displayed on charts and graphs? Well, we go to the flip side of this data file. Okay, in other words, the other side of this window. We're in the same window, but we're choosing a different view. You can click down here to variable view. To go to the variable view, you can see it's organized differently. Each row now represents a variable. In other words, each row represents a column that's in the data view. So I'm going to go back to the data view again so you can flip. You can also go up here to view and switch between variables. We use a toggle to switch between the two as well. So if you look at the variables that we're just looking at, like for instance, sex to represent the gender of the child at birth. Okay, well that's going to be a 1 or a 2. Well, first of all, we want a more descriptive label for our charts and so on and so forth than just sex and age. We want something more descriptive. So we have the opportunity to do that. Some of these columns are going to be obvious. This describes the type of variable. In other words, is it a number or is it a string, letters, so on and so forth. Most of these are input as numbers, but some of them are nominal data. In other words, that number represents a category, like male or female. Others are actual numerical variables. You may have noticed that in the columns, they had little images that represent a ruler for scalar variables, 3 different colored balls for nominal variables or categories. And also, we don't happen to have any ordinal data here, but there'll be different symbol representing ordinal data. So I'm going to take a look just now, for instance, the mother's age. In order to get the charts to print out a more descriptive version, we can type into the label field actually what we want to see, or a better description, which is the age of the mother in years. Unfortunately, we can't use that as a variable name. SPSS will only accept text and numbers for variable names. You can't have any special characters, and you can't have any spaces. So this would not work as a variable name, but that's what we want to describe the data as to someone that's going to be reading it. Okay, and also the has to start with a letter, not a number. So you can come up with something fairly descriptive, but sometimes it's not something that would be appropriate for describing a table. Okay, now every once in a while you might want to check before you do analysis. You might want to check that SPSS is properly displaying the type of variable it is, because there's going to be instances where if it's not correctly describing the type of variable, that you may wind up in a situation where it may not do the analysis that you want, or may not do it correctly. So the variable type is important to us. We want it to be properly identified. Okay, so I'm going to go back to the data view, and I'm going to get let's see. Here we are back in the data view. So I'm going to actually do an analysis here. So descriptive statistics, the type of descriptive statistics that we would do is going to be keyed to the type of variable that we're working with. So for instance, if we're interested in the gender of the baby, we want to know how many male babies, how many female babies were born, that's a nominal or categorical variable. So how would we want to describe that? We might want to describe that as just the number of babies. We might want to describe the number of male and female babies. Might want to describe it as a bar chart, which has side-by-side bars that we could see quickly if there were more female or male babies born. We might want to describe it as a pie chart, with the area of the pie chart representing the number of babies. we might just want a table that describes the frequency, the number of male babies born, the number of female babies born. So how are we going to do that? Well, almost everything we're going to do at this stage when we use SPSS is going to involve going to this tab called Analyze. Okay, later on we might get into a little bit of designing syntax or programs, or have operating SPSS using commands, type commands. But for right now, we're going to use this tab. So I'm going to go to this tab, and it's kind of the statistics we're going to use describe this sample. But the sample describes the sample is a microcosm of the population. So we want to describe this population by using the sample to tell us about it. So I'm going to go to descriptive statistics, and when I'm dealing with a nominal or categorical variable, I'm not going to go to descriptives. These descriptives and explore are the areas that we use for numerical variables. Okay, in fact, you can kind of see there's a graph there and so on. There's a couple of graphs there. Frequencies, there's kind of like a little bar chart there or something like that. Frequencies describe counts of people or things or conditions. Okay, so that's what we're going to deal with in terms of nominal variables. We're going to count them. We're going to describe them by frequencies. So I'm going to click on frequencies, and I think I was talking about the gender of the child. Notice we have a lot of variables, so as we have to tell SPSS what we actually want to use, which variables we actually want to use when we're doing this. I'm going to move in the gender of the child. So there's a few things I can do here. First of all, statistics. Now, SPSS is going to come up here and ask you if you need variable statistics like quartiles and mean. Well, mean is not really appropriate to this analysis. So even though it's here, notice that none of them are checked by default. And in fact, you'd rarely use them for evaluating this kind of variable. So instead, we're going to click off Display Frequency Tables, and perhaps we also might want to display this data as a graph to make it a little bit more understandable. So for now, I'm going to choose a bar chart. Now I have the choice of having that bar chart represent the frequencies, the actual number of children on the axis, or the percentages of children that fit that category instead. So I'm going to get the actual numbers for now. So I'll click Continue, and then I'll click OK. Now, when I click OK, of course, as we noticed before, a output window, a separate window, opens up from the data window that we were working with previously. And you'll notice that the all of the exchanges that we had with SPSS are available here as we go step through the analysis. So, for instance, right now, we opened this data set, and then we opened this data set, and we asked it to calculate the frequencies for the variable named gender to create a bar chart based on the frequencies. Okay, so here we go. This is what it did. Okay, and here we are. Number of male children is 418. That's 52% of the total children. Number of female children is 382. If there were any missing values, it would have highlighted. It would have given us a row for them, I believe. And we can see graphically, we can see that there's a little bit of a difference. There's more male children born than female children. I have no idea if that's typical, if that's reasonable for this kind of data or not. I don't remember how well we randomly selected these 800 from the real population when we did this. It was quite a while ago. So I don't know how representative that is. It takes a little while for my Microsoft programs to start up. Let me close this, get that out of the way. Okay, so I'm going to open a blank document. Now, one of the advantages of SPSS is that they can create very elaborate graphs and tables, and you can then click into SPSS, copy that table, and you can paste it into a document, a word processing program, a report generating program, you name it, any kind of document basically that you want to page layout program, and so on and so forth. And so I'm going to hit paste, and there's our table currently in this new document. And you can use this to generate reports when you're working on your capstone projects or your theses and so on and so forth. And as early as 3 weeks from now for submitting your first homework, which is going to ask you to do this exact process, to do an analysis and just create a simple Word document that has that analysis in it. Now, you may have noticed that I just said copy and I just simply said paste. When you do that, it actually takes the table and pastes it in as a formatted text document. Okay, which means now that I can go in here and I can actually edit. I shouldn't edit the number, right? That's not the right thing to edit. By edit, I mean, for instance, change the text size, maybe make the columns. Notice that if I click into the table, you can see how it's tabbed. You can change the tabbing and so on. If I don't want that to be stacked like that, I want a single height, I can do something like that. I can go in there and maybe this is an important number in this chart. I can go in there and tell it to make that number red or make it bold, right? So you can actually format this table. You can do that because it's in as a rich text format, right? And you can actually go ahead and edit that in here. You can also edit it right in SPSS. Okay, there's as you can with the charts, right? And this window opens up. You have all these editing tools up here. I'll leave it to you to play with those a bit. Okay, so now I can do the same thing with a chart. I'm going to say copy. Okay, now we're going to give this a try. At the end of the last semester, I wound up with kind of but when I updated my version of SPSS, or Word, so I updated something, and it introduced a little bit of a glitch. And pasted it in. Okay, so now I pasted this in. Now, in this case, if I double click on this, right, all I get is image editing for images, right? I can't edit the text in this because I've pasted it in as an image. There's good things and bad things about that. The good thing about that is that it makes it easier for me to resize it and to move it around the document. This over here, in order to resize this or relocate it, is a lot more difficult with word processing program, right? So sometimes you might want to edit your table in SPSS and then say copy. And when you go to paste it into your Word document, if you're happy with the format it's in and everything that it has and the bold and the colors and so on and so forth, when you paste it in, instead of just saying edit and paste, this time go down to paste special. And when you go into paste special, yeah, I have a bug in mind. Okay, when you go into paste special, your version of this, which presumably will not have the bug in mind, your version of this should display, in addition to all of these possible formats to paste it in, should also say paste in as an image, usually a JPEG or some other like PC centric format for an image or something like that. You can choose to paste it in as an image, and when you paste it in as an image, you will have an image pasted in that you can I'm sorry, the table will also be an image, so you can resize that and move it around the document more easily. So that's a little bit of an advantage of editing this in here than somewhere else. If you have a Mac and you have the same problem I do, one of the things you might try is to use this little grab tool that Macs come with automatically. Go up to Capture Selection, and then just copy your table. Copy? Whoops. Copy and either save it to the desktop as a JPEG or some other kind of file. You can change file types there and so on. Give it a name and copy it to there, or you can just simply copy it. Whoops, I'll do that again. Capture. Copy, and hopefully this will work now. I hate when these demonstrations don't work and these silly programs leave you hanging. Oops, there it is. It's pasted in as a image now. And you can see I can resize it very easily. And if I want it in front of this, it's really pretty easy to just drop it up there. Okay, so that's one of the advantages you would have there. Okay, I want to show you one more thing when I'm playing around with in my little exercise here. Okay, and that is that if I go back to SPSS, to the data file in SPSS or variable file, you'll get the same. You get the same menu on both of them. Sometimes you'll get that. Sometimes when you do an install, you might get a little bit of a bug where the image of the drop menus up here, the drop menus, all the selections, they may look a little different in the variable view and the data view. If that's the case, well, if you don't see it if you can't get to it from the variable view, just switch to your data view, and you'll be able to find whatever drop menu in one of the two that you need. So it shouldn't get in the way of operating the software. So I have noticed that bug comes up a little bit. So I'm going to click down on Analyze this time. So this time I'm going to go into Descriptive Statistics. Descriptive statistics, and from there go into descriptives. Well, this selection is designed for numerical variables. So, for instance, let's say I want to know statistics about the age of the mother. Okay, let's say the age of the mother. So I'm going to move that into my variables box. Let's SPSS know that that's what I want to analyze. It's a numerical variable. You can see the little ruler. I want to know what the average age of the mother is for these 800 women, this sample of women. So I'm going to click on Options, and it's already by default going to find the mean, the standard deviation, the minimum, and the maximum. You might remember from class how we calculated those manually, where those numbers came from. I'm going to click off Variance. We know now from our calculations in class that online. When I say in class, I do remember that you're, even though I have another class where it's a brick and mortar class, I do remember that you're doing it from videos. You may remember that the variance is the square of the standard deviation, or in other words, the standard deviation is the square root of the variance. Okay, maybe I want to find the range also. So I'm going to click Continue. I'm going to say OK. So our output window is going to pop up again. You may notice that this output window now has, this output window now has all of the analysis that we've done, almost like one of those calculators with the tape on it, where it just keeps coming up, and the newest analysis is just added to all the others. So if you're doing a lot of work, a lot of different analysis, you can either scroll up and down and see where you've been and where you're going and so on and so forth, or you can bump around just by using this sidebar to get to your analytical work that you've done. So if you have a lot of stuff on here, this comes in handy. Otherwise, you can scroll around here. So in this case, what we've gotten is, I'm going to scroll this up so we can see it a little. Narrow the window so we can see it in the middle. Okay, now there's 800 women. The youngest was 27. The oldest was 42. The range is 27. The youngest was 15. The oldest was 42, hence the range. And the mean age was just a little under 27, with a standard deviation of 6.1 years. That gives us a measure of the variability. That's interesting. That seems like pretty good information. But maybe I can get some more information. So I'm going to go up here to Analyze, Descriptive Statistics, except this time instead of Descriptives, I'm going to go to Explore. Again, I'm looking for the age of the mother. I'm going to move it into this top box dependence list. Don't worry about these two yet. I'm going to go into Statistics. Well, this time, instead of giving me a narrow group of choices that I could check or uncheck, this time it's just telling me, do you want descriptive statistics or do you not want descriptive statistics? So I'm going to check it. It's going to put something in here called a confidence interval. I'll leave it at 95% for now. This is going to come up within a few weeks. Within about 4 or 5 weeks, we're going to be talking about confidence intervals that are a measure of how well you know the sample that you have taken, the mean from the sample you have taken, how well you believe that it represents a good approximation of the true mean of the population. Remember, everything we're doing here with samples, we're calculating the means, the statistics for the sample. But the point is, we're not really interested in the mean of the sample. We want to know what the mean of the population is. We just don't have the capability to measure everybody in the population, so we are forced to use a sample. But we have tools that'll help us know how well, how predictable that the mean that how well the sample predicts the mean of the population. Okay, at least we can quantify how our level of certainty. So I'm going to click OK. I can't do anything else about that. I've checked that I want that. I'm going to clue in here to charts, and it's already going to do something called stem and leaves plot. I'll talk about that in class later on. But we were talking about histograms in our first session here. I'm going to click that off, and I'm going to say, okay, let's do a histogram also. Whenever you use Explore, it automatically does a box plot. Okay, box plot, I believe, was mentioned in your videos from the first week, but I'm going to click OK just so we can see it. Click OK, there we go. Okay, so here we go. So here's our box plot. Here's our results this time. Notice it calculated the mean and the standard deviation just as it did before, and the variance, same results and the range and so on and so forth. But it also calculates a confidence interval, a median, which we didn't have before, our interquartile range, and that I believe has come up. It actually plots a histogram for the values of ages of these women. And I can see it's kind of skewed a little bit towards the older women. There's some women that are older than there are not so many women. Well, obviously, there's not going to be very many women under 15 that are having babies in North Carolina, hopefully, right? So we have some older women that are having babies, especially now. Nowadays, it might even be more skewed to the right. Skewed to the right, we mean that in a normal distribution, the mean and the median, the middle value and the average value, are both in the center of the histogram, right? But what happens is if you have a lot of outliers, a lot of older women that are having babies now, well, the average age now, even though they don't have much of an impact on the median, because the middle woman may be the same anyway, right? Or this middle would be pretty much in the same area, they could have quite an impact on the average age. So what happens is that the median and the average, instead of being the same, the average is pulled away by those higher values from the median. And that's termed right skewed or positively skewed. Okay, so we get a look at that data. That's that stem and leaf plot. This is basically the same thing we have here, except sideways. Okay, and this was popular when we didn't have graphical computers. We didn't have an interface like this that we could do. They use ASCII characters to represent the numbers of women. Okay, and here's our box plot again. Here's our box plot. Youngest woman was 15. Oldest woman was 42. The median woman was about 26 or so. Now notice that the median is not in the middle here, is it? Right? The median is a little bit towards the bottom here because this data is a little bit skewed. So the average is probably up further away from the median. Okay, so we only got a lot of information here. I want to show you one more thing that we can use that'll come up. I'm going to go up here to Analyze. I'm going to go up here to Descriptive Statistics and go back to Explore. I'm going to use one of those other boxes we didn't use yet. Came up the same as before. Well, this time, I'm going to want to take a look at the age of the mothers. Except this time, I'm interested in maybe breaking the age of the mothers up into different groups, right? So for instance, let's say that I wanted to know if the average age of mothers that are married is the same as the average age of mothers that are not married. So I'm going to move marital status, and let me hover over that for a second. Okay, I'm going to hover marital status into the factor list. Well, factor, when you know math, when you factor something, you're breaking it up into parts. So if you have 25 and you factor it, it's 5 times 5. If you have 12 and you factor it, it's 3 times 4. So we're breaking this up into groups. We're going to separate the married women from the unmarried women, and we're going to calculate the descriptive statistics for both groups. So I'm going to click OK. All of the other settings are going to stay are sticking from what we did before. Okay, and sure enough, let's see, the average age for married women is 29. The average age for unmarried women is considerably lower, right? A little under 23. So we noticed a big difference between these two. We also have two histograms now, so we can see if they're more if they're skewed. Well, let's see. For married women, it looks pretty normal, but for unmarried women, there's much more younger women that are unmarried. So this is very skewed, right? There's not that many of the women that are older that were not married. As many women that were older that were unmarried that had babies. Okay, so within that population. So let's take a look at our box plot. Well, our box plot, we can see how dramatic the difference is between married women and unmarried women in terms of the distribution of the ages. Anyone want to hazard a guess what all these bubbles out here are and numbers are? Normally, I'd probably give you guys a little bit more chance to do this interactively, but I wanted to cover this pretty quickly. Anybody have an opinion about what that might be? Yeah, exactly. They're outliers, right? They're values that are so different from the bulk of the values. You can see it here pretty clearly, right? These is so far away from the bulk of the bulk of the sample of women that you might say to yourself, well, gee, maybe there's a reason that that these women are that this data is so different from all the other data. Well, you might have reasons to believe that this valid really is not valid for the study or what you're trying to demonstrate, or you may not. So SPSS chooses what's an outlier based on how far away from the median that it is. In other words, if it's more than 1.5 times the distance from the second and third and fourth quartile, I think, more than 1.5 times the distance from there. Here, it defines it as a outlier. You can change that rule. You can ignore that rule. But SPSS does a simple mathematical elimination. Whether or not you can justify not including those outliers in your sample, that's a decision that you have to make based on why they might be outliers. By the way, these numbers that represents, for instance, 333 represents that subject number. That's the person, that's the woman that's on the 333rd row of the data. So you can actually identify what these values. You can actually go back and look at that value. Perhaps that value is so far away as let's say that turned out to be a woman that was 66 years old. You'd go back there and said, gee, that doesn't sound right. You might check your data. You might find that was a typo and that woman was really 36 years old, right? So there's reason for you want to know if there are outliers and to be able to identify which of the numbers are outliers so you can make better decisions about how to handle that data.